In the previous chapters, you learned the basics of Java and programming. In subsequent chapters, we will discuss more advanced concepts, such as handling input and output, working with databases, web sources, and graphical user interfaces. Unfortunately, as your Java programs become more sophisticated, the likelihood of various types of errors will increase. In this chapter, we will teach you the skills to avoid and handle errors while you program, and to find and fix the errors that will inevitably. We will kick off by zooming into various types of errors. This will be followed by a discussion on exceptions, where we will provide an overview of some common exceptions and review ways to catch them. We will also demonstrate how you can debug and test your applications in Eclipse. Here you can see the various types of programming errors listed, as we already discussed them in Chapter 1. Do you still remember the difference between these? Syntax errors are the equivalent of spelling and grammar mistakes in natural languages. They are the easiest to find. A runtime error is an error which occurs during runtime, or in other words, during the execution of your program. Popular examples are a division by zero, square root of a negative number, a file location which does not exist, etc. A logical error is the most difficult one to detect, since it means your program gives an output, but the output is essentially incorrect. Let's work out some examples. Some popular examples of syntax errors are misspelled class, variable, or method names, misspelled keywords, missing semicolons, missing return type for methods, out of place or mismatched parentheses and brackets, undeclared or uninitialized variables, or incorrect format of loops, methods, or other structures. Syntax errors are typically highlighted in red in Eclipse and are thus very easy to spot. Eclipse will also provide recommendations to fix the syntax error. Here you can see an example of a Java class definition with various syntax errors. Can you spot them? The keyword void of the main method was misspelled. The variable age should be declared as an integer. The declaration of the string name should end with a semicolon instead of a comma. The termination and increment statements of the for loop were not okay. Println is an incorrect statement and should have been println. The println statement should close with a parenthesis followed by a semicolon. The recalculate method needs a void return statement, and the data type of its input arguments should be set to double. And finally, only 2 closing parentheses are needed instead of 3. Now that we've fixed all our syntax errors, we can run our Java class. However, when you run the class, you will see this runtime error saying that a division by zero occurred at line 13 of your program. This code line says monthly pension equals retirement fund divided by years in retirement divided by 12. But since years in retirement has been set to 0, we have a division by 0. Hence, let's set the years in retirement value to 20 for a person retiring at 65 and living to the age of 85. Here you can see our program with years in retirement set to 20. We can now execute it and it will give us a string saying David Johnson will have $41 per month for retirement. At first sight, this looks okay, and we are now convinced that we corrected all the syntax and runtime errors. However, closer inspection reveals that the number 41 is lower than what we would expect. In fact, 10,000 divided by 20 years divided by 12 months is $41 per month. But the program is supposed to be calculating an annual return rate of 10% for all the years between age 30 and age 65. So what's going on here? Well, this is an example of a logical error. The code compiles and executes without error, but logically produces the wrong result. Logical errors are the most difficult to spot because there's nothing to suggest there's an error unless you know what to expect and compare the actual results to the expected results. If you are not careful to review what is happening, you may easily miss logical errors lurking in your code. So let's first try to sort out where this program went wrong. We know the return rate is not being calculated correctly. If you carefully look at the method recalculate, you will see that it returns nothing or void, which is incorrect. It should return the fund amount as a double, such that it is correctly used in the for loop and updated as the loop proceeds. Here you can see the logical error fixed. The recalculate method returns the fund amount as a double. In the main method, both the retirement fund and monthly pension variables are defined as double. We can now rerun our program and it will give the following output. David Johnson will have $1,288.0283 and so on dollars per month for retirement. This makes a lot more sense. Note, however, that it would be nice if we could round the number that is being output. The class Big Decimal offers the developer complete control over how values are rounded. You can see it illustrated here. We first import the class using the statement import java.map.bigdecimal. The retirement fund variable is then defined as a big decimal object with its scale set to 2 decimal points. We also set the rounding to round up when the next digit is bigger than or equal to 5. Also, the years in retirement and rate variables are defined as big decimal. Note how we use methods from the class Big Decimal to perform calculations such as divide, multiply, and add. If we now run this class, you can see the result of the rounding as it prints out. David Johnson will have $1,288.03 per month for retirement. An exception is an event which disrupts the execution of a program. Some examples of common exceptions are a null pointer exception when accessing an object that doesn't exist or has not been initialized, an index out of bounds exception when you try to access an element outside the limits of an indexed object, such as an array, a stack overflow error when too many parameters and/or local variables are created due to recursion, for example, and an out-of-memory error when too many objects are created due to an infinite loop, for example. Let's give some examples. Here you can see two classes defined. We have a class person with name and age variables together with an empty constructor. The class exception examples has two methods, a main method and a print person method. In the main method, a variable employee is defined with data type person, of which the name and age will then be printed using the printPerson method. What do you think will happen if we run the code as is? Well, if we run the exception examples class in Eclipse, you will see that an exception is generated saying exception in thread main java.lang.error unresolved compilation problem. The local variable employee may not have been initialized. We can correct the exception by initializing the employee variable to a new person object, as you can see here. If you run this code, you will see the output null is 0 years old. In other words, Java automatically initialized the name and age fields to null and 0 respectively. Here you can see another example. We extended our previous example with a new class job type with two characteristics, job name and salary band, together with an empty constructor. We also added a job variable to the class person, which is of data type job type. What do you think will happen if we execute this code? Well, we will get a null pointer exception, as you can see right here. Eclipse will also tell us that the exception occurred in the printPerson method. More specifically, the null pointer exception is raised because the job or job name were never initialized for the myPerson object. To deal with this situation, it is advised to require proper initialization as part of the constructor. You can see this illustrated here. Both the person and job type classes have constructors which now initialize all the variables. In the main method, you can now see a manager job type object and an employee person object created with proper values for their variables. When this program is run, it will give the desired output, saying Bob Little is 47 years old and works as a manager. Another common exception is index out of bounds. You can see this illustrated here. The class defines an array, hours worked, representing the number of hours worked on each day of the week. A for loop is then used to sum all these numbers and calculate the total hours worked, which is then output to the screen. Take a closer look. What will happen if we execute this code? It will generate an array index out of bounds exception. Why? Well, as you can see, the array has 5 elements. Remember that the first element has index 0 and the final element index 4. Now take a look at the loop conditions. The terminating statement says I less than or equal to hours worked dot length. The value of hours worked dot length equals 5, since there are 5 elements in the array. In other words, in the final iteration step, the program will try to access the element at index position 5, which does not exist, since the final element of the array is located at index position 4. Hence, the array index out of bounds exception. How do you think we can remedy this? Well, we just have to replace less than or equal by strictly less than, and it will work. In this class, we define an object, myStrings, which is an array list of strings. It then starts a for loop whereby in each step the for loop variable I is added to the myStrings object. What do you think will happen if this code snippet is executed? It will raise an out-of-memory exception. Do you know why? The problem is the termination criterion of the for loop. The iterator, int I, is initialized with a value of 0 and increments by 1 with each loop. The loop is supposed to terminate when the value of I goes below 0, but it will never reach this condition because it is increasing, not decreasing. This might be easy to spot here, but if your termination condition is dependent on a variable or method result, you might not immediately see where infinite looping is possible. Here's another example. We have a class with three methods: main, displayMe, and printMe. The main method calls the printMe method. The latter calls the displayMe method, which again calls the printMe method. What will happen here? Well, the two methods call each other back and forth without end, and Java will raise a Stack Overflow error. The stack is the part of your memory allocated for parameters and local variables. This can overflow when two methods infinitely call each other. Now that we have seen some examples of exceptions, the question is, how can we handle them? In Java, this can be accomplished using a new structure called a try-catch block. This essentially allows you to try executing a piece of code to see if an exception is thrown using the try statement. If none is thrown, the program will proceed normally, but if one is thrown, you can catch it using the catch statement and specifically indicate what should be done next. This prevents your program from crashing and at least allows you to recover some information before it terminates. The finally statement allows you to execute code unconditionally. Let's illustrate this with some examples. Here we have a class error with a main method. We defined a numerator and denominator integer variable and set them to 10 and 0 respectively. We then use a try statement to calculate their ratio. Obviously, this will give a division by 0 and an arithmetic exception object will be thrown. This exception can be caught in the catch statement where the error denominator should not be 0 is printed to the screen. Let's see what happens if we define the numerator, denominator, and ratio as double instead of integer. When running this class, no exception will be thrown and Java will output infinity. The reason is because both Java's floating point data types, double and float, implement the IEEE 754 standard where a division by 0 is defined as infinity. Suppose now that we do want to raise an exception when dividing by 0 in our example. This can be done explicitly by using the statement if denominator double equals 0, throw new arithmetic exception, as you see illustrated here. If you run this in Eclipse, you will see that the message denominator should not be 0 is now displayed. Let's now also illustrate the finally statement. This statement is always executed, no matter if an exception was thrown or not. In this example, you can see that we added a finally statement to our class definition. We also changed the denominator to 2. If we run it, you can see that the output will be 5, which is 10 divided by 2, together with the message, finally was reached. Let's see what would happen if an exception would have been thrown. We change the denominator back to 0 and run the class. The exception message, denominator should not be 0, is now displayed together with the message, finally was reached, as expected. As we will discuss more extensively later, try-catch blocks are often used for input and output operations. You can see this illustrated in this class, which first asks the user for the loan amount, interest rate and term, and then calculates the monthly payment. To do so, we first create a scanner object, which allows us to scan simple text and parse primitive types or strings. In our example, it is based on system.in, which represents user input from the console. The next int and next double methods parse integers and doubles from the text entered by the user. If a user enters the character 5, the next int method will parse an integer with value 5. If a user enters the word Bart, this cannot be parsed using the next int method, and an input mismatch exception will be thrown, as you can see illustrated. Also, note the finally statement where the scanner object is properly closed. The previous example can also be worked out with a try with resources block, as you can see illustrated here. By adding the declaration and initialization directly to the try block, the resource will automatically be closed no matter how the rest of the try block completes, with or without exception. So, in other words, we no longer need a finally statement in this case. It is also possible for a method to throw an exception, which is then handled in another method calling it. You can see this illustrated here. The method scanValues uses a scanner object to enter the loan amount, interest rate, and loan term from the console and store it in the values array. As indicated in the method header, it can throw an input mismatch exception, which is not handled here, but in the calling method, which is the main method. Note that the scanValues method also includes a finally statement to properly close the scanner object. In the main method, you can see that we catch 3 exceptions, being input mismatch exception, arithmetic exception, and index out of bounds exception. In this chapter, we started by discussing various types of errors, such as syntax errors, runtime errors, and logical errors. We reviewed common exceptions and how to handle them using the try-catch statements. We also illustrated how you can debug and test your applications in Eclipse. Many of the ideas discussed here will come in handy as we start to develop more sophisticated Java applications, accessing external data from the console, files, databases, and/or web resources.